Hey everyone, my name is Olaf, and I just released an add-on development course to make it easier for you guys to develop your own add-ons. And you will learn how to develop add-ons with input values, as well as buttons with custom objects. Next, you're going to learn how to import CSV and text files into Blender to create visualizations and so on. And this one has the data animated year to year. And then you will also learn how to write add-ons with multiple scripts and then connect them all together. I'm also going to teach you how to make drop-down menus like this one. And I will also show you how to use custom icons and add them to your add-on. And then at the end of the course, you will use everything that you have learned to create a complex music visualization add-on. And I'm going to show you the workflow to develop more complex add-ons like this one. And you will get all this and much more for a very decent price. And at the end of the course, I'm sure you will know how to develop your own add-ons. So make sure to check it out on Blender Market and Gumroad, and I see you there. In this video, I will teach you the basics of Python that you need to start learning about add-on development for Blender. So let's start off by going into the scripting workspace. And then let's add a new script. And I'm going to increase the font size. Let's set it to 16. And then next, we can delete the cube and press Shift A and add another cube. And then you can copy the text into the console. And let's change the scale and location. As you can see, when we press enter and run the script, and we have now generated a new object, but this time the location on the z-axis is changed, as well as the dimensions. Now let's try to add the code to the text editor and run it. So copy the code, paste it in, and when you try to run it, you will see that it fails. And that is because we have not yet imported BPY, which is the Blender module for Blender functions and so on. And when we run the script, you can see that we now have the object. Okay, so now we know how to add objects, and now we're going to go into the very basics of Python programming. So let's start off by defining a variable, which is a way to store values. So let's store the value 3 and then add it into the location. And let's add it to the scale as well. And variables are very useful for editing multiple values at the same time, as you can see. So next, we're going to add some randomness to the code. So let's import the random function. So from random, import randint. So let's get random values between -10 and 10. So use the function randint, and then parentheses, and then -10 to 10. And then we still have the variables in the primitive cube function, and as you can see, we get the random location on the z-axis every time we run the script. Okay, so now we know how to add random values, which is very important in programming. And then press A, then X to delete everything. And then I'm going to save the project, and you can save it wherever you want on the computer. And then select the folder, then give it a name, and then save. And next, we're going to add a for loop, which repeats a block of code multiple times, which is also very important for add-on development in Blender. So for I in range. And then we can repeat this block of code 20 times, for example. And then let's select the code below and indent the code. You can also press Tab to indent. And by indenting, we put the code within the for loop. As you can see, we now have 20 cubes with random locations on the z-axis. And then we can do the same for all axes. One variable for each axis, so x, y, and z. And let's add that to the location. And when we run the script, you can see that we have cubes at random locations on all the different axes. Okay, so let's press A, then X to delete everything. And then next, we can take a look at the while loop, which essentially does the same thing, but as long as the condition holds true. So let's add 1 to the C variable for each while loop, so that it runs the code 20 times. As you can see, it started with 0, and then it added the cubes until C was equal to 20. And then next, we can take a look at the if statement. So if A is equal to 1, we will run the code below. So let's add a cube, for example, and use that code. And else, we can add a monkey instead. So if it's not equal to 1, it will add the monkey instead. And because A is equal to 1, it's going to add the cube. Now, if we change the A variable, we get the monkey instead. If you want to add comments to your script, you can use the hash symbol, also known as the hashtag, and then you can write whatever comments you want to add to the script, and you're not going to get any errors because of that line. We can also print text by using the print function. So let's print hello, for example, down in the console. And as you can see, it prints hello. And if we do it in the text editor, and then run the code, you can find the print under a window, and then system console. As you can see, we have hello. Okay, so next we're going to take a look at functions. So you need to define a function first. So let's define add things, and then 2 parentheses, and then we can add some code under this function. So let's add a cone, for example, and then let's paste it into the script. And then next, let's add a cube and grab it a bit downwards on the z-axis. Then copy the code, and I'm going to change the location to -1.84. And then next, we can call the function and get everything from that function with just a few characters. And as you can see, we have the cube and the cone. And we can add the function multiple times. And let's change the script slightly. So let's print a few times. So, let's type in Blender is great. And then we run the function. And when we go into the system console, you can see that we get the text 3 times. Now let's try to combine a for loop with a function so that we can save a lot of space. So let's do it like this, and we can delete 2 of the function calls, and let's just print Blender. Okay, and then we run the script, and as you can see, we have now printed Blender 30 times. And these are the most important things that a Blender user needs to know about Python before going into add-on development. And I just released an add-on development course to make it easier for you guys to develop your own add-ons. And you will learn how to develop add-ons with input values, as well as buttons with custom objects. Next, you're going to learn how to import CSV and text files into Blender to create visualizations and so on. And this one has the data animated year to year. And then you will also learn how to write add-ons with multiple scripts and then connect them all together. I'm also going to teach you how to make drop-down menus like this one. And I will also show you how to use custom icons and add them to your add-on. And then at the end of the course, you will use everything that you have learned to create a complex music visualization add-on. And I'm going to show you the workflow to develop more complex add-ons like this one. And you will get all this and much more for a very decent price. And at the end of the course, I'm sure you will know how to develop your own add-ons. So make sure to check it out on Blender Market and Gumroad, and I see you there. In this video, I'll show you how a Mac user can get the system console for prints and so on. So when we go into the window, you can see that there is no system console. So to get that, we need to right click on the Blender logo, then go into options and then show in Finder, and then right click once again and then go into show package contents and then open Blender through the terminal under Mac OS. And then it opens Blender. And then we can use that terminal as the system console when we need to print any text or take a look at the errors for our code. So I'm going to increase the font size as always to 20. And then let's import BPY. And let's print some text. So let's type in print and then hello world, and then we can run the code. And instead of going into the system console, we can just go to the terminal and you will see the print output. So that's how a Mac user gets the system console. In this video, I'll show you some great free resources that you can use as supplementary material for the course. And I first recommend taking a look at the different Python courses available for free on YouTube. And I also have a playlist with the free Python tutorials for Blender. These videos do not go as in-depth into Blender programming as this course does, but they can still be useful. And when I'm saying that these are supplementary resources, I mean that you do not have to watch any of the Python tutorials on YouTube or any of these tutorials to be able to follow along to this course. So just see this as supplementary information. And then for asking questions about Blender and programming in Blender, I recommend using the Blender section of Stack Exchange. And Stack Exchange is the go-to place both for professional developers and amateur developers as well. Another great resource for creating add-ons for Blender is the Blender Python API documentation page. Here you can find all the documentation you need for Blender specific modules and functions, and I found this website extremely useful myself. So these are the resources that I'm recommending, and I hope you find the rest of the course useful as well. In this video, I'll teach you how you can get the code from people's add-ons to get inspiration for your own add-ons. And it's very simple. You just need to unzip an add-on. So let's extract the files. And there we have the Python script. So all we need to do is to go back to Blender and open the Python script. So let's go to open and then find the unzipped folder. And then open the Python script. So whenever you need to figure out how someone made a feature in their add-on, you can just download the add-on, unzip it, and then check out the Python script on how it's made. In this video, you're going to learn how to import spreadsheets and text documents into Blender, and then print them out into the Blender viewport and the system console. So let's start off by creating a simple spreadsheet using Google Sheets. So I'm just going to give it a name. And then let's add a few names. Let's just add Olav, and then Andrew, Gleb, and Ducky. And then give each of these names a few data points. And then we need to download the spreadsheet. So download. And let's download it as a CSV file. And then let's rename the CSV file. I'm just going to call it test. So it's test.csv. And then let's go into Blender and create the import script. So I'm going to start off by importing CSV, which is a module we need to import CSV files, and then import BPY as well, which is the Blender module, which we need for Blender functions, and then write with open, and then add some parentheses. And inside these parentheses, we're going to add the location of the CSV file. And you can find the location by going into the properties and then copying in the location. The code is the same for Mac users. The location is just slightly different, and I will provide an example file for Mac users in the course material. Okay, so let's type in text.csv, and then we need to read out the CSV. So readout equals list CSV reader, and then we're going to read F, which is the opened document, and then I'm going to save. So you can just save it where you want on the computer. I'm going to open a new folder and then give the document a name. Okay, and then let's do a test print to make sure that it works. So read out, and then let's print it. And in the system console, you can see that we have the data. So what I'm going to do next is to move it into the viewport as well. So press Shift A, and let's add a text, and then copy the code for adding the text, and then paste it into the text editor. And we can remove everything within the parentheses because we do not really need them. And then next, we need to set the text object as the obj so that we can edit it. And then next, obj.data.body equal to string, and then we're going to use the readout text. So we're going to change the text of the text object to the readout variable, which has the CSV data, as you can see. Okay, so next we're going to create a text document and import it into Blender. So I'm going to create a Google Docs document and then give it a name. You can just call it whatever you want, and let's just write in some test text. And once that's done, we're going to turn this into a .txt document. So download, and then .txt. and then we can find the location. And the location is the same, so we can just change the document type in the code. And I'm also going to turn the import CSV into a comment, because we will not need that in this case. And then let's type text.txt. And this time we're not going to use the CSV reader. So just f.read. And turn this into a function. And when you run it, you can see that we have the text. But the only problem is that we get a few strange characters. And this tends to happen when we use Google Documents.txt documents. So I'm going to use the notepad instead to generate the .txt file. And you will see that that works a lot better. So let's once again write some test texts. And then we're going to save this as a .txt file. And I'm just going to overwrite the previous text file. So file, save as. And then I'm going to go into the documents, select the previous one, and then overwrite, replace it, and then let's delete the previous text and run this script again. And as you can see, we have the text without any of the weird characters. So now you know how to both import CSV files and .txt files. And I hope that was helpful, and see you in the next tutorial. In this video, you're going to learn how to print text from a Python script into a text file or a CSV file. So let's get started, and we're going to start off by importing BPY. And then next we need to tell the program which file it's going to write to. So let's define the output file, and then find the text file that you want to write to. You can just create a new text file. And then let's copy the location, which you can find in the properties, paste it, and in order to make it work, turn backwards leaning slashes into forward leaning slashes. And then at the end, add the file name. The workflow is the same for Mac users, so make sure to find the file location. And then we're going to define the text that we want to write to the text file. So text lines equal to bracket hello Andrew, for example. You can write wherever you want. And then we need to open the text file. So f equal to open, and then output file, which we defined earlier, and then write W. And with W, you erase all the text that used to be in the file and replace it with the new text lines. And then f dot write lines. Now let's set txt lines, so that we write the txt lines into the file. And then make sure to close at the end. And when you run the script and open the text file, you can see that we have the print. And if you change it to A, you can see that we added an additional line into the file. And when you run W, you can see that it replaces the previous text. So that's a useful difference to know when you write your files. And then next we're going to add the text to the CSV. And you can create CSVs using Google Sheets. And in CSV files, information is often comma separated. So let's use some commas and some numbers. And then next, let's change the name of the lists. So I'm going to change it from text lines to CSV lines. And then let's try to run the script. And then let's go to the file. And I'm going to open the Excel file. And as you can see, we have the output. And that's it for this video. I hope you learned something, and I hope you enjoy the rest of this programming course. In this video, you're going to learn how you can create a script that will turn a spreadsheet full of data into a 3D graph animation. Okay, so here we have a Google spreadsheet, and you can find the link to the document in the course material. So let's turn it into a .csv file. And then let's go into the folder where it's downloaded. And I'm going to move the file into the documents. And then let's change the name of the file. So let's rename it to GDP. And then enter to confirm. And then let's go back into Blender and start writing the script. Okay, so let's start off by deleting everything in the viewport. So press A, then X to delete everything in the viewport. And then let's increase the font size as well, so that you can see what I'm writing a bit better. And then let's create a new script. And I'm going to start off by importing PPY, which we need for the basic Blender functions. And then also CSV, which we need to read .csv files. And then let's also import all the math functions by typing in from math import star. Okay, so next we need to open the .csv file. So with open, and then parentheses, and then we need to add the file location of the document. So let's go to the folder and then the properties, and then let's copy the file location. And the script is the same for Mac users. You can check out the example scripts for Mac users in the course materials. And then type in the file name at the end. And then you also need to make the backward slashes forward leaning. And then we're going to read the file that has been opened using csv.reader. And then line length is going to be the variable that counts how many rows / countries there are in the document. And then we're going to create a for loop, which will generate the text, graph, and animation, one loop for each country. And then let's add a plane that we can use for the graph. And then copy the code and paste it in. And I'm going to remove everything except the size inside the parentheses. So let's set the size to 1. And then next, we need to set the bar equal to the plane. So bpy.context.object. And then let's save before we continue. You can save the .blend file wherever you want on the computer. I'm going to save it here. And then give the file a name. And then next, I'm going to set up the spacing between each of the bars, as well as the width. And then we're going to create another for loop, which we will use to edit the vertices of each of the bars, so that the origin point is set correctly for later scaling, so that it only scales in one direction. And we're also going to set up the placement and bar spacing, so that we get the correct spacing between the bars. And then next we need to set up the frame number, which is equal to 1 at the beginning, so that we can keyframe. And then let's set a equals 1. And then we're going to create another for loop, which we will use to animate the bars. So let's start off by setting the frame. And then next we're going to set the scale of the bar for each year. And for that we're going to read the data from the spreadsheet and then divide the yearly data by 4 so that the bars do not become too long. And then next I'm going to keyframe each of these values. So 1 year for each loop, and then each loop gets a keyframe on the scale. And then we're going to add 20 frames between each value. So each year is 20 frames long. Okay, so let's save one more time. And then we can do a test run. And as you can see, when we go back to the layout, we have the animation for the graphs for each year. And to make the animation linear, we can press T in the timeline and set the keyframe interpolation to linear. Okay, and next let's delete everything and go back to the scripting. And now it's time to add the country name for each of the bars. So let's add some text. And then we're going to set the text variable, which is a new variable that we're creating, equal to the text that we just added. And then text.data.align x is going to be on the right side so that the text expands to the left. And then we're going to align it to the center on the y-axis. And then let's create another save before we continue. And then when we run the script, you can see that we have the text, but we also need to rotate it. So press R, set then 90 to rotate it 90 degrees on the z-axis. And then we can copy that data. And instead of copying the line directly, we're going to use a bit lower level code and use the rotation value inside this Euler. And the rotation value is 1.5708, which is half the pi value. So 2 pi is a 360 rotation. And then next I'm going to use a transform translate function that you can get by pressing G, and use that to move the text a bit down for each line of data. So we're going to set the placement number multiplied by the bar spacing plus 0.5 so that it moves a bit upwards. And then at the end, we're going to set the text.data.body to the same as the name in the spreadsheet, so that the text of the name is going to be the same as you saw in the spreadsheet, as you can see. Okay, and then we can add a solidify modifier as well to add some thickness to the bars and the text. So let's add a new solidify modifier. And I'm going to add a solidify modifier for both the bar and the text. So let's set the thickness to 0.3 for both of them. And make sure to change the name of the second modifier as well. Okay, so now we have thickness. And the scripting part of this video is basically done. So let's save before we continue. And then we can set up the rendering, the materials, the lighting, and so on. We can start off by adding the floor. So Shift A and add a plane, then press S to scale. And then next, we need to add an HDRI for the background image. So let's go into the world settings and then change to environment texture, open, and you can find the HDRI in the course materials. You can also go online and choose between a variety of free HDRIs. Okay, so next we're going to add a material to the floor. So let's use a glossy shader and let's make it much darker so that we can more easily see the text and the movement of the bars, or at least the scaling of the bars. And then in the render settings, let's enable screen space reflections, which gives us a slightly different type of reflections in the render. And next we're going to add some materials for the graphs and the text. So let's go into the material settings, add a new material, and I'm going to change to the glossy type. And then let's give it a blue color. And then I'm going to copy this material to every second country. So select Sweden, Austria, Singapore, Iceland, Ireland, Switzerland, and then the graphs as well. And then press Ctrl L, and then we get the materials linked to all of these selected objects. And then I'm going to change the color slightly, something like this, so that the contrast is a bit larger. And you can also press G, then Z to grab the plane on the Z-axis, which is upwards and downwards. And I think this looks nice. So just play around with the colors and roughness and see what you like. And then press numpad 7 for a top view. And let's save before we continue. So Control Shift S, and then let's add a camera. So press Shift A, then add a camera, and then press Control Alt numpad 0 to move the camera to your current view. I'm going to rotate the camera and set it around here. And make sure that everything is within the frame throughout the whole animation. So let's set the end frame to 400. And then move the camera slightly, a bit backwards, so that everything is within the frame. Okay, so I think this looks nice. And then next, we need to add another add-on, which enables us to get a counting number. So use the link, which is provided in the course materials, download the add-on, and then let's go into Edit, and then Preferences, and then we need to install the counter add-on. I'm going to go to the Downloads, and then select the add-on, and then install it, enable it, and let's move it here. And we're going to use this add-on to count the current year. Okay, and then press Shift A, and let's add the text. And then press R, set the 90, rotate it 90 degrees on the Z-axis. Press S to scale, and then let's go into the text settings enable the add-on, and then let's set the number of decimals to 0, go to the first frame, and the value for the first frame is going to be the first year of the dataset. So it's going to be set to year 2000. And then we're going to press I to keyframe the value. And then let's go to frame 380, which is of course 19 times 20, because we have 20 frames between each value. And then let's set it to 2019 and I to keyframe. And then press T in the timeline and set the keyframe interpolation to linear so that the year changes at a constant rate. Okay. And then next we're going to press Shift A, add some more text, and press R, set then 90. And this one is going to be the title for the animation. So let's write GDP per capita. Set it around here. And then let's add a material. And let's set it to diffuse. And I think that looks fine. And then we also need to add a material for the numbers. So let's use the same diffuse material that we just added. And I think that looks nice. Okay, so now we're almost done with the tutorial. So the next step is going to be to animate the camera so that we get a three-dimensional feeling. So press N, and let's set camera to view. And we need to make sure to add some thickness to this text as well. So add the solidify modifier, and then let's add some thickness like this. And then we can just use the same value as we used for the text for each of the countries. And then let's add a solidify modifier to the year as well, and set the thickness to 0.3. And then I'm going to grab it on the z-axis like this. Okay, so everything is looking fine now, so let's go into the output settings and set up the render. So we're going to set the number of samples to 100, which should be enough for this type of animation. If you want a 4K animation, just set it to 200 instead of 100, which is 1080p. And then I'll set the frame rate to 30 FPS. And then you need to select a folder for the final animation. And then give the folder a name. And then select the folder. And then give a name to the animation. And these are going to render out as PNGs. And then you can convert them into an MP4 file later. Okay, so now we're going to animate the camera by keyframing. So let's set it around here. And go to one of the first frames. And then press I to keyframe, and keyframe both the location and the rotation. And then let's move the camera up here. And then press I and I to keyframe. And as you can see, we now have the animated camera as well. And then I'm going to press T in the timeline so that the keyframe interpolation is set to linear, so that the movement or the speed of the movement of the camera is constant throughout the whole animation. And I think this looks really nice. Okay, so let's pause the animation. And I'm going to change the last keyframe slightly. So right click to delete the keyframes, and I'm just going to move it up here. And then press I and I to keyframe once again. And I think that looks a bit better. So the next step will be to render the animation. So let's save one more time before we start the render. And then go to render, and then render animation. And that's it for this video. I hope you enjoyed it and learned something new. And I hope you enjoy the rest of this course as well. In this video, you're going to learn how to make a simple add-on with 4 different buttons. So let's start off by increasing the font size so that you can see what I'm writing. And then I'm going to hide the sidebar. And let's start off by giving the script a name. So I'm just going to call it Simple Buttons. And next we're going to use a template for the installation info so that we can install it in the preferences. I'm also going to copy the import PBY, which is the Blender module. Okay, so let's give the add-on a name. Let's call it Buttons. And then the author of the add-on, that's you, so just type in your name. You can also type in the Blender version, even though it doesn't really make much of a difference. And I'll set the location to view 3D. And you can add a simple description if you want to. And for the category, I'm just going to leave it blank. Okay, so next we need to save so that we have the script if something crashes. So I'm just going to create a new folder. And then you can save the file wherever you want on the computer. Like this. And the file will include the Blender script as well. And then let's add a template, and we're going to use the operator template. So let's copy the node operator class and then use it in our script. So press Ctrl V to paste in the script. And what we insert into this operator will tell the program what it's supposed to do when we click a button. So it's sort of the script for the button. So I'm going to set the ID name to object.1. You usually need a dot in the ID names. And for the name of the operator, I'm going to call it button operator. And then next, under BL_options, we're going to register and unregister the button operator so that it works. And then let's remove the pull function, and we're only going to use the execute function in this case. So let's add what we want the button to do. So let's go into the viewport and then press G, then set to move it on the z-axis. And then we're going to copy that code into the script. So Ctrl V. And then I'm going to change the orient type to local so that it moves it on the local z-axis. Let's remove the rest of the script because it's not really needed. And then let's save. Just press Ctrl Shift S to save a new file. And then next we need to add another template. So let's add a UI panel simple template. And then we need to copy the class. So Control C, and then let's go back to our script, and then Control V, and then I'm going to change the name of the panel. So let's just call it custom panel, and we can remove this comment. And for such a simple add-on, I'm not going to add any label, but I'm going to add an ID name. And then for the space type, we're going to set it to the left side of the viewport. So set the space type to view 3D. And then it's going to be under tools in the region type. So tools with capital letters. And then next we need to add the operator into the panel. So copy the operator name. And for the text, we're just going to use the operator label. So we'll just set it to button operator 1 BL label, which is nothing in this case. And then for the icon, we can use the icon viewer, which you can find in the preferences by enabling the icon viewer. And then let's go into the icon viewer and select one of the icons for the first button. So let's choose this one, for example, which is the arrow, or the triangle. Now let's save before we continue. So press Ctrl Shift S, click on the plus sign, and then save. And then from bpy.utils, import register and unregister. And registering a class loads the class definition into Blender, where it can be available for us to use in the add-on. So let's create a new list with underscore classes equals, and then use brackets and indent, and type out the classes that we have in this add-on. So the first one is the button operator, then use a comma, and then custom panel, and then a bracket once again, and then we need to register and unregister the classes. So let's use a for loop. Let's call it CLS, and then in classes, and then we're going to use the register class function for each of these classes. So register class, and then inside the function CLS. And then we just copy this code and change it to unregister, and do the same when we unregister the classes as well. So we'll just use the same for loop and unregister. And then at the end, we add 2 lines that are used for testing. So if underscore underscore name underscore underscore equals equals, and then underscore underscore main underscore underscore, and we register inside this if function. Okay, so let's save another time and try to run the script. And when we take a look at the tools and use the button, you can see that the add-on works. And since the tool section is quite thin, I'm going to add 2 buttons for each row. As you can see, the movement is on the local axis, so when we rotate it, it's going to go in a different direction. Okay, so let's copy the first button operator and make a few more buttons. So copy and paste, and then let's change the second one to button operator 2, and then object 2 for the ID name, And let's make this one negative instead on the z-axis. And then let's add another operator inside the panel. And let's change it from button operator 1 to button operator 2. And then for the icon, we can use a triangle that points downwards. And then we need to register the class as well. So let's just copy this one and change it to 2. And when you run the script, you can see that we now have 2 buttons. And since the movement is local, it's going to go in the other direction. And if we rotate it back to its original rotation, you can see that the downwards button pushes it down, and the upwards button pushes it up. Okay, so let's copy the button operator and add 2 more buttons. So for button operator number 3, I'm going to scale up the cube. So press S, then 2 to scale it 2 times. Okay, so let's copy and paste the code into the script. And we can remove everything except the scale and the orient type. In this case, it's not really necessary. And then under the panel, we also need to add the operator. So let's copy the previous operator, paste it in, and change it to 3, both for the ID name and the text. And then we need to find an icon for this button as well. So for this one, I'm going to use the add icon, which is just a plus sign, and then copy the code and paste it into the icon inside the operator. And then next, we need to add the operator to the list of classes. So let's set it to button operator 3. And as you can see, we now have another button. So going to add another cube, and let's add the 4th operator for the 4th button. So we need to change the resize values to 0.5 instead, so that the object shrinks when we press the button. And then let's copy the code, and instead of using the add icon, we're going to use the remove icon, like this. And then we also need it in the classes list. And when I ran the script, it failed, and that is because I forgot to change the name of the operator. And I'm also going to remove a layout row so that the 2 first buttons are next to each other. And the reason why the add-on does not work properly is because I forgot to change the ID name of these 2 operators. So let me just make sure that's fine. And when we add a cube, you can see that the add-on now works. Okay, so let's save the Blender project before we continue. So Control Shift S, and then click on the plus sign and save. And then I'm going to save the script as well, so that we can install it from the properties. Just going to call it simpleaddon.py for Python. And then let's go into the folder. And then I'm going to compress the Python script into a .zip file. So archive format to zip, and OK. And then we go back to Blender. And then we can install the add-on in the preferences. So let's select the simple add-on zip, and then enable it. And if we now close Blender and reopen Blender, you can see that the add-on is now installed and still there, so that you do not have to run the script each time you open Blender. That's it for this video. I hope you learned something and that you now understand a bit more about add-on development in Blender. In this video, you will learn how to make a very simple calculator that has input values and prints into the viewport. Okay, so let's start off by going into the scripting workspace. And then press X to delete the default cube. And let's add a new script. And we can increase the font size. And then next, we need to import BPY, which is the Blender module for Blender functions and so on. And then we're going to import the different types, like the panel and so on, so that we don't have to type in bpy.types in front of each of them. Okay, and let's also add the property group, which we need for storing the values from the input field. And then we're also going to import the properties. And there are 3 different types of properties that we're going to import. We're going to import the string property, and then comma, and then next we're going to import the pointer property, which we will use for the input values, and then lastly the float property, which we will use for the numbers. Okay, and then let's give the add-on a name. And then let's use the panel template. You could of course memorize all of this, but it's not really useful. It's much faster to just copy the template for when you need a panel or an operator. I'm just going to call it my panel. And then let's change the label to text. And then the same for the ID name. And then we're going to place it in the side panel in the viewport. So view 3D for the space type. And then we need to set the region type to UI. And that is the standard placement for add-ons. And then let's set the name in the panel to text add-on. And then we can remove most of the code that is below the draw function. And then next we can go into the templates. And I'm going to copy the simple operator. We're going to use that one to create a button for our add-on. So let's change the name to text operator, and we can remove bpy.types because we already imported the operator type, and then set the name to some.thing. Doesn't really matter as long as you have a dot in between. And then the label is just going to be print. And then you can add a description of the operator if you want to. I'm not going to bother with such a simple add-on. And then let's copy the execution function and add it to the text operator. And then inside the execution function, we're going to add the text and add the print text into the text data. So you can use the add text function, which you get by adding the text and copying the text from the info window. And I'm going to save. You can save it wherever you want on the computer. Give it a name and then save. I'm just going to call it text add-on and press enter to save. And then next we need to add our print text to the text. So press X to delete. And then let's create a variable obj. and set it equal to the text so that we can refer to the text and edit it. And then obj.data.body is going to be equal to the text that we want to print. Okay, so let's say hello Blender. And we're doing a very simple test string first before we get into the calculator, so that you get a better understanding of how it works, because the calculation development is a bit more complex than this. Well, let's go back to our add-on and add the return. And then under the draw function, we can add everything that we need inside the panel. So let's set the scene equal to context.scene.yourProperties, so that we can get the properties that we need for the calculation later on. And then let's add a column. And then we're also going to add the operator that we need to print the test text. So call.operator, and then we need to refer to the operator, which is referred to by typing in some.thing. Then let's save before we continue. And then let's list all of the classes, and then register them and unregister the classes. So we have the following classes: my panel, and then the text operator. And then we need to register and unregister, which we need to run any add-on. So let's define the register function and add a for loop, which will run through our two classes. And then we register them. And then we also need to add the unregister function. So define unregister. And then once again, we need to use a for loop to run through the classes to unregister them. And then we add the test at the end as well. So if name equals main, then register. Okay. And then let's save before we continue. Click on the plus sign and then save. And then make sure to comment your properties, because we do not need them yet. That's for the calculation. And then we're going to change it to category for the last line of the panel info. Okay, and when we run the script and press N, you can see that we have the text add-on. And when we click on the print button, we get the text. And when we change the text and run the script once again, you can see that the print changes. And then let's try to change the label as well. As you can see, the text on the button changes. Okay, so the next step of the tutorial is to create the calculation add-ons. Let's save one more time before we continue. So let's change the label to calculate for the panel. And then next, we need to import the math module so that we can use some different math functions. And let's change the name of the add-on to math add-on. And then let's add our properties and the plus sign for the button. And when we run the script, you can see that there's no button, and that is because we need to add the properties first, so that we can add the multiplication functionality. So let's add a class, and this one is going to be called add-on properties. And this is where we're going to store all of the properties that we need for the input. Okay, property group, and then string. And the string is going to be the text that you can use to name the text object. I'm not actually going to do it in this video, and it's going to be your homework to figure out how you can add the text to the name of the generated text. And you will learn how to use the string property in the physics tutorial that is included in this course. It's very similar to how you use the numerical values in the float property. And my tip to solving this homework is to take a look at the physics script and see how the string property is implemented into the panel there. And then next we need to add value 1, which is a float property, and this is going to be the first input value for the multiplication. And for the name, description, and default, we can just copy the code from the string property and then paste it into the float property. And we're going to set the default value to 1. And you can also edit the description. The description does not really matter for such a basic test add-on, so change it as you like. And then let's add the second value. I'm going to change the name, and then also make sure to add the parentheses that we need for the property, like this. And let's add it for value 2 as well. Okay, and then we need to register the class. So add-on properties, and let's save. And you also need to add the comma. And then next, inside the register and unregister function, we need to tell the program what properties we have. So let's use pointer property, and then inside the pointer property, we're going to add the add-on properties as the type. And then we delete it in the unregister function. And this will make sure that the input values work. Okay, and then let's save. Click on the plus sign and then save. And then next, we need to add the properties into the operator. So let's change the text to plus. And then we can copy the scene.yourProperties into the operator. And then we can import the string value, which is equal to scene.string, which we defined earlier. And then value 1 equals scene.value 1. And then the same for value 2. And these are the values that we created in the properties class. Now let's save one more time. And then let's add the multiplication text. So string round value 1, and then let's add 2 decimals, plus, and then let's add plus as a string, and then string round value 2 with 2 decimals, and then plus equals, and then plus once again. And then we need to add the 2 numbers together. So round value plus value 2, and we need to change it to value 1, of course. And then we can have the 3 decimals for the answers. Okay, and let's save. The next step is to add the input values, in other words, the properties. So let's create 2 properties, one before the operator and one after the operator, so that we have the button in the middle. And then let's refer to the float property value 1. And then let's copy, paste, and set it to value 2. And then let's add another column at the end. Okay, so let's save one more time. The next step is to turn these default values into numerical values instead of being strings, so that we can calculate properly. And then I'm also going to change the descriptions of these float properties. Let's just set it to value to add. And then when we run the script and delete the previous text, let's set a value 50, for example, and then we add them. And as you can see, we now have the calculation output. And let's try multiplication instead. And let's run. And you also need to make sure that the operator has a different label. And when we run it, you see that we have the multiplication. Let's try a different value for the second one. And as you can see, it works. And let's try with an X instead. And as you can see, when we run the script, the button changes. Okay, and if you want to change the number of decimals, you can change the second value in the round function. So set it to 4, for example, and then let's set the number of decimals to 5 for the answer. And then let's try to multiply these values. And when we run the script and multiply, you can see that we have 4 decimals for the first 2 values, and then 5 decimals for the answer. And you can also set it to 1 and run it. As you can see, we have less decimals. And that's it for this video. I hope you learned something, and I hope you have a better understanding on how to use input values and how to combine those input values together in mathematical functions. So I'm going to save, click on the plus sign, and then end the video. In this video, you're going to learn how to make a basic drop-down menu, which is very useful for when you need to store a lot of different options and values in an add-on. So let's start off by increasing the text size so that you can see what I'm writing. I'm going to set it to 18 and then hide the sidebar. And then next we need to give the add-on a name, so I'm just going to call it drop-down. And then we're going to use the template for info. So use the add-on add object and copy the BL info and import BPY. And then let's go back to the drop-down add-on. And then I'm going to change the name to drop-down, and then write in your own name as the author. And then I'll just set the location to view 3D, because it's going to be in the side panel, and then we don't really need the description for such a basic test add-on. And for category, I'm just going to set it to generic, and then we need to import a few things before we can start typing in the actual add-on. So from bpy.props, import, and then parentheses, enum property. And then we also need to add the pointer property, and enum property will be used to store the drop-down values, and the pointer property will be used to point to those values. So let's set a parenthesis. So now we import those two properties. And then next we need to import some types for our classes so that we can add a panel and so on. So let's import panel. And then next we need to import the operator for the drop-down menu, and then the property group, which you will see later. Okay. And then next we need to create a class, and this first class is going to be the properties. So I'm just going to call it my properties, and this is where we're going to store all of the drop-down values. And then we're going to use the enum property to store the names and the values for each of the drop-down options in this add-on. So let's define it as me enum, and then enum property. Now, before we insert the values, let's just give it a name and description. So name equals, and I'm just going to call it dropdown, and then comma after the name, and then description equals, and then I'm going to write in applies data. And then let's end the string and type in a comma. And then in the next line, we're going to add the items, which is the names and values for the dropdown. I'm using a string type both for the value and the name of each option, because we can just convert it later. So going to call this one 1, and then 1 meters. And then we can just copy this one and add the comma as well, and do it a few more times, and then we can just change the values later. And then let's end it with a bracket and a parenthesis, and then let's change the values. I'll set it to 1, 2, 3, 4, 5, 6, and then the same for the name. And these are the names that will appear in the drop-down menu. And then next, let's add a simple operator and use this as the template in the drop-down add-on. And then we're going to change the name of the operator to measure. And then we can remove the bpy.types because we have already imported the operator. And then we can remove the tooltip. And then let's set the BL ID name to generate. And then the label to measure with a dot in between. And let's go to execute. And before we can add an object to the scene, we need to set the scene context. So scene equals context dot scene. And then next we need to define my tool. So equals scene dot my tool. Okay, and then we're going to add a cube. So press Shift A and add a cube, and then paste it into the text editor. And let's delete everything within the parentheses. And then next I'm going to press G, set then 1 to grab it on the z-axis, and then copy the code into the text editor. And let's delete this code so that we only have the value for the transformation and the orient type, which is global. And then we're going to use the value from the drop-down menu to move the cube on the z-axis. So the drop-down menu is going to decide where the cube is going to end up when we run the script. Okay, so let's save before we continue. So save, give it a name, and you can save it wherever you want on the computer. So I'm just going to call the file dropdown, and then press enter to save. Okay, so next we need to create the panel for the drop-down menu. And for this, we're going to use a simple panel template so that it becomes easy and fast. So let's go to UI panel simple. And then we can just copy the panel code, or at least the upper lines, like this one. We do not need the rest. And then let's go back to our script. And then just paste the lines. And then let's change the name of the panel first. So I'm just going to call this one object underscore pt, and let's call it custom panel. And since the panel type is already imported, we can just remove that part. And then let's change the label. So let's call it my panel. And then I'm just going to change this one to custom panel. And then for the space type, we're going to set it to view underscore 3D. And then for the region type, I'm going to set it to UI. And then for the context, let's set it to object mode. Okay, so now we need to create the drop-down menu. But first, let's set the scene context. And then we need to assign the drop-down menu to the scene. So let's call it my tool equals scene dot my tool. And then next we need to create the actual drop-down menu. So let's set up the properties for the drop-down menu first. And for this, we will use the my tool, which is set to the scene. And then next, we're going to set the my enum as the properties, which we have already defined in a previous class with all of the different measurements. And then we will write nothing inside the text string. And then next, we're going to create the actual operator, which is the drop-down menu itself, so layout.operator. And then this drop-down menu will execute the code that is under the measure operator above, under execute. And then at the end, we need to register all of these classes so that we can run the script. So let's create a list, classes equals my properties, comma, measure, and then comma object pt custom panel. And then we're going to use for loops to run through these classes in the registering and the unregistering below. So let's define register first. So from bpy.utils import register class, and then for CLS, which is the for loop in classes, and then let's run through the classes, register class, and then CLS. And then next, in order to add the enum values to the drop-down menu, we need to set bpy.types.scene.myTool equal to pointer property with the type equal to my properties. Okay, and then we also need to unregister. So def unregister, and inside that function, we're going to write the following: from bpy.utils import unregister class. So the same as above, but with unregister instead. And then we're going to add another for loop but this time we're going to add unregister inside the for loop. So for CLS in reversed classes, unregister underscore class, and then CLS inside. Okay, and then at the end we need to delete the bpy.types.scene.myTool with the pointer property. So del means delete in Python, and then if name equals to main, and then register. Okay, so let's try to run the script. So press A, then X in the viewport to delete everything. And then when we run the script, you can see that we get some errors. So let's go to the system console under window and figure out what was wrong. And the problem turned out to be with the panel. So we need to add the category as well, which is something I forgot. And you're going to have a lot of errors when you run your scripts. So that is to be expected. So I'm just going to set the category to tools. I also did the ID name and label in the wrong order. So make sure to change that as well. And when we run the script and press N, you can see that we have the drop-down menu. And the selection is going to choose the location of the cube on the z-axis. And that's it for this video. I hope you enjoyed it, and I hope you learned something new about programming drop-down menus in Blender using Python. In this video, I'm going to teach you how to create an add-on which enables you to add custom objects like the bowl, as well as having input values like the name, the number of generated objects, and so on. So let's get into it, and we're going to start off with a new script. Let's increase the font size, and then next we're going to import BPY, which we need for the Blender functions. And then we're also going to import math. So from math, import star, which means import everything from the math module. And then we're also going to import random, which you can write in two ways, both from random import star and import random. Okay, and then next we're going to import all the bpy.types so that we don't have to write it into every panel operator and so on. And we can just write operator instead of typing in bpy.types.operator. And then next we need to import the properties which we need for the input values that you saw in the add-on. So from bpy.props, then we're going to import three different property types. So string for the texts, and then the pointer property, which we're going to use when we register the other properties, and then the float property, which we'll use for numbers. Okay, and then let's save before we continue. So save as, and give it a name. You can save it wherever you want on the computer, and then press enter to save, and then press A, then X to delete everything, then Shift A, and let's add a sphere. And then we can add some rigid body physics to the sphere as well. And we're then going to copy the code that we get from the info window into our script. So let's set the bounciness to 0 so that we get the code. And then let's copy the code into our script. And then let's add the rigid body physics as well to the sphere. And then press X to delete, and then we can run the script. And as you can see, when we play the animation, we now have a sphere and rigid body physics to the sphere. Okay, so let's press X to delete, and then let's add a plane. And then we're going to copy the code for the plane and increase the size. And since this is going to become a very large plane, maybe the floor of the scene, I'll set the size to 500 and the location to -4. Okay, and then we need to add the physics for the plane. So let's add some rigid body physics, set the type to passive, because it's going to be passive and not move. Then set the shape to mesh. And then let's set the bounciness to 1. And then we can copy the code into the script. So let's paste the code. And then let's delete everything in the viewport. So press X to delete. And then let's run the script. And as you can see, we now have both the sphere and the plane. And then let's go back to the first frame, go back to the scripting workspace, and then let's save before we continue. So click on the plus sign and then save. Okay, and then press A and then X to delete everything in the viewport. And then we're going to turn all of these lines into comments so that we do not run them when we create our bowl code. Okay, so press Shift A and add a cube. And then we're going to use that cube for the bowl code. And then let's set the size to 20. And we can remove this part of the code because it's not really necessary, and set the location to -10. Okay, so when we run the code, you can see that we have the cube down here. And we're now going to edit the cube using code to create our bowl. So press Tab for edit mode. And in the overlay settings under developer, we need to enable indices so that we can see the vertex number. And we're going to use these later to delete the top face. Then next, we need to select the cube in the script. So let's set the variable obj equal to the active object, which is the cube. And then we're going to scale up the cube on the x and y axis 3 times. So let's set the obj scale on the x-axis to 3. And then the obj scale on the y-axis, which is 1 to 3. Which is the same as pressing S, then Shift Z, and then 3. Like this. Okay, so let's press Tab to go back to object mode. And then press X to delete. And when we run the code, you can see that we now have the same object. And then next, let's go into edit mode and copy the code both for going into edit mode and deselecting everything in edit mode. And then we need to go back to object mode to select the vertices, because we need to select the vertices in object mode. So we go into object mode and then we paste the code. And then next, we can save one more time. We can just press Ctrl Shift S to create a new save. And then I'm going to set X equal to 1 and then do a for loop for selecting the top face. So we need to select 4 vertices. So obj.data and then vertices. And then we're going to use the X variable that we created and select them. And then for each loop, we're going to add 2 so that we select 1, 3, 5, and 7. And then we're going to go back to edit mode afterwards. So that's the same as selecting these vertices. and then pressing X to delete. So let's copy the code for deletion. So you need to select in object mode and then delete in edit mode. And then let's delete the object and see if we get the same result. As you can see, we now have the object without a top face. And then next, we need to go back to object mode. So just going to add another object and then get the code for object mode. And then let's paste it into a script. And then next, we need to add a modifier to the object so that we get the bowl shape for the object. So let's run the script and then go into the modifiers. And then let's add the subdivision surface modifier. And as we increase the number of subdivisions, you can see that we're starting to get a smooth bowl. And we can also enable auto smooth so that we can add smooth shading without the smooth shading messing up the object. And then next, we need to add the subdivision surface modifier to the script. And instead of just copying the code from the info window, we're going to add the subdivision surface modifier to the OBJ object directly in the script. So let's create a new modifier. Let's call it bowl shape, and it's a subdivision surface modifier. And then let's add the modifier to the OBJ object, which is the active object, in other words, the bowl. So set it to bowl shape, which we defined earlier. And then let's set the number of subdivisions to 4. And then add the auto smooth to the script as well as shade smooth. Okay, then click on the plus sign and then save. Okay, so let's delete the bowl and add a new one. As you can see, it works great and has a great smooth shading. So next we're going to add the solidify modifier, which adds some thickness to the object. And we can play around with the thickness of the object in the solidify modifier. So let's try some different values. And then next we need to add the modifier to the actual script. And this time we're also going to add it directly to the object. Let's create a new modifier and call it thickness. And then make sure to tell the program that it's a solidify modifier by typing in solidify with capital letters. And then we're going to set the thickness, and we can set it to 0.15. And in order to make the rigid body physics simulation work properly later, we need to apply the modifiers. And we can do that in the code as well. So let's apply the subdivision surface modifier first. So the bowl shape, which is the subdivision surface modifier that we created first. And then let's apply the solidify modifier as well. Thickness. Okay, and then let's save one more time, save as, and then let's run the script. As you can see, when we select it, the modifiers are applied. Okay, so now that the bowl is finished, we can add the rigid body physics to the bowl. So let's go into the rigid body physics settings, add the rigid body physics, and this one is going to be passive. It's not going to move. And the shape will be mesh. And then for the source, it's going to be the base. And the bounciness we set to 1. And then we can copy this code into the script. So hold in Shift and select all of them. Then copy and paste it into the script. And then we're also going to set the name of the object. So let's call it bowl. Okay, and then let's try to run the script. So press X in the viewport to delete the previous bowl, and then run the script. And as you can see, we forgot one line, and that is the add physics line. So I'm just going to scroll up a bit and find the line that we're missing, which is this one. And then let's paste it in above the passive line. And when we delete it and run it, you can see that we now have the bowl, and it's named bowl as well. Okay, so let's save one more time. And then we're going to create the operator for the bowl so that we get a button for creating the bowl. So for that, we're going to use a template. Let's go to Python templates. And let's add a simple operator. And then we can copy that code. So let's copy this part of the code. Go back to our script. And then let's give the script a name. I'm going to call it physics.py. And then we can paste in the operator. And let's remove the pull function. We only need the execute function for this one. And then let's change the ID name. Let's call it add.bowl. And we'll use the ID name to refer to this operator later on in the script for the panel and so on. And then let's just call it add bowl. And then we need to add the description as well. For the operator, adds a bowl with passive physics. And then next, we can add the script for adding the bowl inside the execute function. So let's copy the code for the bowl. Control C, then Control V inside the execute function. And then we need to indent the code so that it's within the execute function, like this. And then we're going to do the same for adding the spheres. But for the spheres, we need to add a for loop as well, because we're going to add multiple spheres with random locations. So let's copy the simple operator script we used for the first operator. And then let's paste it in. And make sure to copy the return code as well. And then we can copy the code for adding the UV spheres with the physics. So let's paste it in and make sure to indent the code as well with tab. And because we're going to add multiple spheres, we need to add a for loop. And the for loop will run the code as many times as specified in the panel in the input value. So for I in range, and then int. And we use int because we want a whole number, because this is a for loop and it can't run a for loop 3.5 times, for example. And then make sure to indent the code so that everything is within the for loop. And then next, we're going to create the properties that we will add to the panel for the input values. So let's create a new class. we're going to call it Addon properties. And then property group. And then inside this class, first going to create the string. And this one will be the name of the generated spheres. So name of the object to add. And then default is going to be nothing. So the default option will not have any text. And then we add in the text by typing it into the input. Okay. And then we can copy these lines of code. And let's change the name from string to size. And I'm not referring to the size of the objects, but to the size of the value. Okay, and this is going to be the number of spheres. And then the default value is going to be 1. Okay, and then let's add another one, size 1. And then in the name, we're going to set it to size. And then we can also edit the description. So let's write size of objects. And then let's change the end of the description as well. So size of objects that are added. And then we can copy these lines of code and set size to equal to the name range. And this is going to be the range of the randomness of the generated spheres. And then in size 3, we're going to set the bounciness of the generated spheres. And this is going to edit the bounciness inside the rigid body physics settings. And then we can set the default value to 0. And then let's change the name of the operator. I'm going to call it add spheres. And then we can remove the bpy.types because it's not necessary. And then let's also remove the comment. And we obviously need to change the ID name of the spheres operator. Let's set it to random.lock. And then for the label, we can just write add spheres. Okay, and then we can also change the description of this operator. So something like this. And then next, in the execute function, we need to set the scene and add all of the input values that we just created under the properties. So let's save before we continue. And then first we can add the string value. So string equals scene dot string, and this one is going to get the string values from the properties class. And then the same for the size. And then we can copy this one and just paste and type in 1, 2, 3, and so on. And this is going to move all of these input values into the operator so that we can use them to generate the spheres at random locations with all of the properties that we added into the panel. Okay, and then for the location, we're going to use random values. So size 2 times a random uniform value. So random.uniform, and then we're going to use values between -1 and 1. And then we can copy the same code and add it to the Y and Z axis as well. Like this. And then we can set the input value has the value for the rigid body restitution, which is the bounciness of the spheres. So let's set the restitution to size 3, which is the bounciness. And then next we're going to use the string input to set the name of each of these spheres. So let's add another line. And then the context dot active object dot name equals string. Okay, and then let's copy this operator and create a new one. And the new operator is going to be for the plane. So let's paste in the operator, and then we can delete the old code in the execute function and replace it with the code below. So let's remove the comment and then copy the code and paste it into the execute function like this. And then let's indent the code, and I'm going to change the label to add plane, and let's change the name of the class as well. Okay, so now we have the third operator. Let's also change the description. Now the next step of the tutorial is going to be to create the panel so that we get the actual add-on. So let's save before we continue. Ctrl-Shift-S, and then we can use the panel template. So go to templates, Python, and then let's add a simple panel template. Now let's copy the code and then go back to our script. And then let's paste it in. And we're going to change the name of the panel class. So let's call it add-on panel. And then we can remove bpy.types because we already imported that. And then let's remove the comment. And then for the label, I'm going to change it to rigid particles. And then the ID name, I'll change it from object pt hello to just object pt random. And then we're going to place it in the side panel in the viewport, as is the standard for most add-ons in Blender, at least the paid ones. And then set the region type to UI. And then we're going to call it rigid particles here as well. Okay, and then we need to add the code to the draw function. So let's set the scene. So scene equals context.scene dot your properties. So now we're going to add all of the input values into the panel, as well as the buttons to create the bowl and so on. So let's create a new save before we continue. And now let's add a column. And then we can start adding all of the input values. So let's start off with the string property. So we'll call .prop, then scene, string. And then let's add a column in between and copy the code of the property, and then change the name of the property to size. And this is going to be the second input value. And then we can add size 1, size 2, and size 3. And all of the specifics for these values are already written into the properties class. And then let's add the first operator, which will be the button for the random placement of generated spheres. And I'll just make the icon a UV sphere. Then let's copy this operator and paste it down below. And let's change the icon for this operator. And for the bowl, I'm going to use a U icon, which you can find under Events. And then select U, and then copy the code. So event underscore U. And then we will refer to the operator by using its ID name. Okay, and then let's copy the code and paste it. And then let's change the icon. And for this one, I'm just going to use mesh underscore plane. And then we need to refer to the operator. Just add dot plane. And then let's save before we continue. So click on the plus sign and save. And then I'm going to list the classes so that we can register them and unregister them. So add-on panel and add-on properties and the operators as well. And then next we need to register all of these classes. So def register, and inside the function we're going to use a for loop to run through all of these classes to register them. So register all of the classes, the CLS for loop. We also need to add a line to tell the program what properties we have. So we're going to refer to the add-on properties class. And then let's copy the register script and unregister the same classes. And then let's also delete the properties. Okay. And then we're going to add 2 more lines for testing the add-on. So if name equals main register. Okay, and let's save one more time. Click on the plus sign and then save. Now next I'm going to go over the script and make sure that I've done everything correctly. So the first mistake I found is that I made the numbers for the different values into strings, but these need to be actual numbers. And then next, I'm also going to edit the name of one of the operators. I forgot to give a custom name to the bool operator. So I'm going to change the name from simple operator to add bool. Okay. And then I'm also going to edit the unregistering, where I forgot to add un to the unregistering. And then let me just edit one more thing before I run the script. And that is that I forgot to change the panel context to category. Because we need categories for this type of panel. Okay, and when we run the script and press N, you can see that we have the add-on. So let's give the spheres a name. I added this feature mostly just for you to practice adding string values into add-ons. Now let's try some random values and add the spheres. We can try to increase the range like this. And then let's add the bowl and the plane. As you can see, we need to move the plane a bit down in the script. But when we play the animation by pressing space and start from the beginning, you can see that the balls fall down. And because the bouncing value was set to 1, we have a lot of bouncing. Okay, so let's go back to the scripting workspace and save before we continue. And then we're going to move the plane on the z-axis and find the right position. So we have to move it around 14 units on the z-axis downwards. So let's change the plane value for the location. So instead of setting it to -4, we'll set the value to -18.5. I did a slight mistake here, so I subtracted the last value as well. So it becomes -18.5. And when we run the script and add the ball, you can see that the ball is right on top of the plane. Okay, so now we're pretty much done with this add-on. I hope you learned something new about add-on development and that you now understand how to use input values for add-ons, which is very important, especially when you want to create more complex add-ons. And when we add the ball and spheres with a lower bounciness and a larger size, you can see that we now have a functioning simulation add-on. It's not the most useful add-on, but I added as many functions as I could into one add-on so that you understand how all of the different input values and the buttons can work together. In this video, you'll learn how to import icons that are not included in the Blender icon library into add-ons in Blender. So let's start off by going into the web browser and let's find an icon that we can use for this add-on. So when you search for icon, make sure that the type is transparent. So something like this. And then we need to save the image. And because we're going to use this image in an add-on, we need to create a new folder for this image and the add-on. So let's create a new folder, and you can create it wherever you want on your computer. I'm going to call it custom icon. Okay, and then select the folder and then save the icon in the folder. The next step is now to create a script that will import this image into the add-on. So let's go back to Blender, and we're going to start off with a template. So use the add object template, and then let's import the info and import BPY. And then make sure to import the OS as well. And then the name of the add-on is just going to be custom icon. And then the author, that's you. And then you can change the Blender version if you want to. It doesn't really matter that much. And I'm going to leave the location empty. And in the description, I'm just going to write custom icon. And the category is going to be left empty as well. And then next, we're going to use another template. And this time it's going to be a panel. So let's use a simple panel template. And then copy the code. I'm going to copy the register function and the unregister function as well, so that we do not have to write that. And let's paste it into our custom icon script. And then let's save before we continue. You You can save it wherever you want, and I'm just going to call it custom icon. And then press enter to save. And then we need to change the names in the class. So let's call the panel icon panel. And then let's remove the comment. And for the label, which will be the title above the button, we can just write icon. And then for the ID name, I'm going to change it to icon as well. We do not need to change the space type and the region type. And we need to remove the hello world text. And then next, we need to reference the icon. So my icon equals pcall, and then my icon. And then add the icon to the operator, which means that we're going to add the icon to the button. And to store the icon once it's imported into Blender, we're going to use a preview collection. And then next, I need to copy these curly brackets like this, and then we need to import the actual icon into the add-on. So import previous, and then the pcall value is going to be equal to previous new, which allows us to import the icon. And then we're going to tell the program where the icon can be found, which will be in the icons folder. And then the script will be placed right next to the icon folder. Okay, so now we have the loading of the icon set up and the name of the icon as well. As you can see, the name is iconimage.png. And then we need to set up the preview collections. So we're going to use main equal to pcall, which has loaded the icon. And then next, we need to register the icon panel class. Let's save once more. And then next, we need to unregister and remove the preview collection, which is where the icon is stored. So ppy.utils.previews and that remove at the end. And then next, we need to clear the preview collections. So preview underscore collections dot clear as a function, and then let's save once again. And the code might seem a bit complex, but all we're really doing is to import a PNG image from the folder that's right next to the script. And then let's make sure to define pcall in the icon panel as well. And then I'm just going to set the category to render, because we're rendering using this button. And then use underscore underscore init underscore underscore dot py. And then we need to create a new folder just for the icon image. So I'm going to call it icons, which is what we said the folder was named in the script. And then make sure to zip the whole folder. And then you want to go into the preferences and install the add-on. And enable it. And as you can see, we now have the custom icon inside of Blender. And that's how you add a custom icon into your add-on in Blender. In this video, you're going to learn how to connect multiple scripts into one add-on, which is very useful for once you start developing more complex add-ons. So let's start off by using a template. So let's use an operator template, which we will use to generate the button execution. So let's copy this part of the script. And then let's give the script a name. I'm just going to call it tool operator. So this script will be exclusively for the tool operator. And then let's import bby and also import random, which we will use to generate random numbers for the location of the generated objects. And then let's change the name of the operator class. So I'm going to call it tool underscore ot underscore operator. And then let's remove the comment. And the ID name is what we use to refer to this operator in other scripts. And the label is going to be the name of the operator. And we're only going to use the execute function. And then let's add a for loop for generating the cubes. And this is a very simple script. We're going to repeat this block of code 50 times. So we're going to generate 50 cubes with the random locations between -20 and 20 on all axes, as we have done before. Next, we're going to go into the scripting workspace to get the cube code. So let's add the script to the workspace as well. And I'm going to increase the font size. And then next, let's delete the cube and then add a cube and copy the script and paste it into the code. And we're going to replace the location with the x, y, and the z variables, which contain the random code. Okay, and then let's save the script. And this is going to be the tool operator. Let's create a new folder for the multi-script add-on. And then select the folder. And then let's save the script inside the folder. And then next, we're going to create a new script for the panel. So let's use a panel template and copy the panel class. And then next, let's give the new script a name. So I'm going to call it interface underscore panel .py for Python. Okay, and then let's paste in the script from the template and start off by removing the comment, and let's give the panel a name. So let's call it interface underscore pt underscore panel. And for the ID name, I'm going to change it to menu name. And for the label, let's call it random cubes generator. And for the location, I'm just going to place it in the right side panel in the viewport, which is the standard for most add-ons. And for the category, which is the name of the add-on in the side panel, I'm going to call it random. Okay, so inside the draw function in the panel, I'm going to set the scene equal to the context scene. And then next, let's add a row. And then next, let's add the operator for the button in the panel. So let's refer to the operator that we created in the first script, which is named cubes.create. And then for the text of the add-on, I'm going to type in random cubes. And then let's also add an icon. So make sure that the icon viewer is enabled under add-ons. And then let's copy the mesh cube icon. And then let's save before we continue. I'm just going to click on the plus sign and then save. And then let's save the script as well inside the folder. And then save as. Now next we need to create a script that registers and unregisters the whole add-on. So let's call it underscore underscore init underscore underscore .py. And let's use the very simple add object template to add the info. And let's change the name of the add-on to random add-on. And then insert your name in the author. And I'm just going to set the location to view 3D. And the description is going to be random cubes add-on. And for the category, I'm going to give it a generic name. Okay, so let's import the two scripts that we created. So let's import the interface panel scripts and the interface that comes with the scripts. And then let's also import the operator. So from tool operator, import the operator class. Okay, and then next we're going to type in the classes. And these are of course the classes that we created in the two other scripts. And then next we're going to register and unregister these classes. And I'm going to do that in one line. So register, unregister, and then the classes. Next, let's save the blend file. So click on the plus sign and then save. And then let's go into the folder that we created. And then we need to archive the folder and turn it into a .zip file. So compress the folder. And I'm going to turn it into a .zip file and then OK. As you can see, we now have the add-on as a zip file. And then go into Edit, Preferences, and let's install the add-on under Add-ons. And then once the add-on is installed, we can enable it. Then let's go back to the viewport, press A, then X to delete everything. And then when you press N, you will see that the add-on has appeared and that it's working. So that's how you create an add-on with multiple Python scripts and connect them all together. I hope you learned something. In this video, you will learn how to develop a music visualization add-on, and this is definitely going to be the most complex add-on that we're going to develop in this course. Even though the add-on is quite complex to develop, the user experience is very good and simple. As you can see, you only need to select the song that you want to visualize, and after just a few seconds, we have the music visualization. And the workflow to create such a visualization would normally take at least 10 to 15 minutes, but through Python programming and the add-on that we will develop, we will shorten that process down to just a few clicks and a few seconds of waiting. And since this is a quite complex add-on, you should expect to get a lot more bugs and errors when you run the script. But I'll show you how to deal with those and get your add-on to work. Okay, so let's start off with a new project, then press A, then X to delete everything, and let's go into the scripting workspace. And then we can create a new script, and I'm going to increase the font size to 18 so that you can see what I'm writing. And then let's start off by importing BPY, which is the Blender module for Blender functions. And then press Shift A, and then let's add a UV sphere. And we're going to copy this code into the script, and we can delete everything except the scale or the radius of the sphere. And then next, we're going to set the frame to frame 1, so that we can add the music and the visualization from frame 1. And then next, we're going to add a texture. And this will be the texture that we're going to animate. So let's set it to the Stutchy texture. And then we're going to change some of the settings inside the texture. So let's set the type to hard. And then next, we're going to set the noise scale to 0.5. So this is the size. Next, we need to add a modifier for the texture, and that is going to be the displacement modifier. And then we're going to add that texture to that displacement modifier. This is how we're going to do the music visualization. And let's set the mid-level value to 0. And then we're going to keyframe the strength. So press I to keyframe. And then we need to copy the code and paste it into the script. And then let's add the modifier as well into the script. And there are of course many ways to add modifiers to a Python script. You can do it both high level, like we do it here, and the lower level way that we have done in previous videos in this course. So let's add the displacement modifier and the mid-level equal to 0. Paste it in. And then next, we're going to add the texture to the displacement modifier. So the object is of course the sphere, and the modifier is the displacement modifier. And then the texture for the displacement modifier is going to be the texture that we just created. And we did not give that texture a specific name, so it has the default name texture. Okay, and before we continue, let's save the project. So go to File, and then Save As. And then let's create a new folder, and you can save the folder and the project wherever you want on the computer. Going to create a music folder, then give the project a name, and then press enter to save. And then next, I'm going to add a keyframe to the strength value in the displacement modifier in the script. So bpy.context.object.modifiers. We're going to refer to the displacement modifier, and then dot keyframe, so that we can set the keyframe, and we're going to insert it into the strength value, and do that at frame 1. And next, we're going to add the materials. So first, we need to set a variable equal to the active object, which in this case is the sphere. And then we're going to create a new variable called mat for material. And then bpy.data.materials.get with material. And we will create that material in the following if statement. So if mat is none, so if there's no material, generate a new material called with material. And then we're going to add 2 more lines to make that material the active material. And then we're also going to append the material if there are other materials in the scene. And by adding nodes to the material, we can easily edit the material using a Python script. So let's start to play around with the principal shader. So let's choose a color, and as you can see, we get the color in the info window, and we can paste it into the script. And if you want a specific color or the same color as me, you can just copy the value. And then next, we're going to get the code for the metallic value. Make sure to copy the material name. And the metallic value is going to be 1, and then the roughness value is going to be 0. Copy and then paste it into the script. And then let's save one more time. Going to name this one 2. Then next, we're going to go into the graph editor and add the music using code. So let's copy the code to go into the graph editor, which is the UI type F-curves. And then let's bake the sound to F-curves and find some music that you want to visualize. And then bake. And when we go into the layout workspace, you can see that we have the animation. So let's go back to the scripting workspace, and we can copy the code for the sound bake. And instead of just having one bake, I'm going to remove this one and add multiple with different frequency intervals. So let's go to key and bake, then select the music. And then next, we need to choose the frequency interval. So the first one is going to be from 0 to 250. And we'll set the attack time to 0.001. And then we can copy the code into the script. And we're going to set the file path to self.filepath, which will be the file that we import. And then next, we need to deselect this value so that we can bake the next displacement modifier as well. So bpy.ops.graph.hide, and then unselected equals false. And then next, we're going to save. And then we can copy the code from the first displacement modifier and then paste it in below. And then we need to change the name, of course. I'm going to set it to display.001 and change the name for the rest of the code as well. And then we're going to bake. And this time it's going to be from 250 to 600. And then bake sound to F-curves. And then type in self.filepath in the file path. And then let's add the hide line as well for the graph. And then next, we're going to add the subdivision surface modifier to increase the number of polygons. And then I'll set the levels to 4, both for the viewport and the render, to increase the number of subdivisions. And then let's copy the code into the script. And then next, we can go into the viewport and get the code for smooth shading. So go to Object, and then Shade Smooth, and then copy the code into the script. And then next, we're going to copy the displacement modifier one more time. Let's call this one Displace 2. And this one will have the interval from 600 to 100,000. So basically the rest of the range. And then at the end, we're going to reveal all of these graphs, because we're no longer afraid or concerned about affecting the other graphs when we bake the sound. Okay, and I'll say one more time. Then let's go to the layout, and then into the video sequencer. And then we're going to add the music, and we'll add the music in the script as well. So this is a great way to get the code. We also need to add some additional code. And then let's add it to the first frame. Like this. And then we can go back to the script. In order to import the music to the video sequencer, we first need to set the scene to the video sequencer. So to do that, we write the following script, which sets the scene to the video sequencer. And then in the video sequencer, we're going to add a sound strip. So new sound. And this is, of course, the music that you add to the visualizer. But we have it in the video sequencer as well, so that we get the sound in the scene and not just the visualization. And then we're going to jump to the last frame of the music. And when the current frame is set to that last frame of the music, we can set the end frame there as well. So let's go into the video sequencer, and this is what we're going to do using code. So we will set the end frame to the current frame, which in this case is at the end of the music. And once the end frame is equal to the length of the music, we can go back to frame 1. Let's set the frame back to 1 using Python, and then I'm going to save one more time. You can save as many times as you want to. And then next, we're going to set the number of samples for the render and the viewport. So let's copy the code. And I think 64 samples should be enough. You don't really need a lot of samples in Eevee. And then next, we can set the scene back to the viewport, as well as setting the render engine to Eevee. Let's set the scene equal to bpy.context.scene, and then set the render engine for the scene to Blender Eevee. And then in the next line, we can add the code for View 3D, which is the 3D viewport, instead of being in the video sequencer. And then we can also add bloom to the scene. So let's enable bloom, and then we can copy the code. And in order to save the add-on user some time, we're going to add a camera and set the camera in front of the visualization. So let's add a camera. And then we need to look through the camera and press N, and let's set the camera to view. And then we can go into item and take a look at the location and the rotation of the camera, and then copy that information into the script. Okay, so let's copy the camera code. And then we can edit the location first. So let's set the Y value to 13.4, and then 5, and then 1.22, and 0.0075 for the Y-axis for the rotation, and then minus 3.12, which we got from the item rotation and location information. Okay. And then next, we're going to save, and then we will set up the URL settings so that we get the background image, which gives us really good reflections. So let's add an environment texture, open, and if you want to get the same background image as I use, you can just Google free HDRI, and then go to this website, and download Factory Catwalk. And then you need to unzip the file before you can open it. So I'm going to right click and extract the file. And then go back to Blender and open the background image. Factory Catwalk, and then this file. And then when we go into rendered view, you can see that we have the background image. And we're going to include this background image in the add-on and then add it to the background. So first, we need to delete any world that was in the scene before. So let's remove them. And then next, we're going to add a new world, and we're going to call this world music background. So new world equals bby.data .worlds.new, and then background underscore music for the name of this new world. And then we're going to use nodes for the new world as well. And we're also going to get the node tree for the background. Okay, and then we're going to set the scene for the world equal to the new world that we just created. And then next, we're going to add an environment texture to the background, so that we can add the HDRI to the background. And then let's give the environment texture a name. We can just call it environment, doesn't really matter that much. And then we also need to set the location, which is just the location for the HDRI. Okay. And then next, we need to add the HDRI to the background. And we're going to include the HDRI in the file by having it in a folder in the add-on. So let's refer to the HDRI folder, and then the file name, which is Factory Catwalk 2k.hdri. And then next, we need to set the environment image equal to the file that we just selected. So we're going to load the file, and then we're going to connect the environment texture node to the world output. And as you can see, there is a typo for links, but I will fix that later in the video. You're going to have some typos, but you will usually find them by getting the errors and then finding the line with the error. I left some typos in the script so that we can practice reading the error messages later. And then next we're going to go into rendered view so that when the user adds the music, it's automatically going to go into rendered view. And then let's also add a plane. I'm going to scale up the plane, and this is going to be the floor. Let's save one more time. And then next we're going to switch back to the 3D view and add the plane in the script. So let's copy the code for the plane. And then let's paste it into the script. I'm going to set the size to 400 and remove most of the code. Let's set the location to -6. And then we need to select the plane so that we can add some materials to it. Let's say one more time. And then we're going to add a principal shader with a metallic value of 1 and a roughness value of let's say 0.155, and then make it a bit dark, so something like this. You can of course add any color that you want to add and play around with the different values. And then let's create a new material. We're going to call this one floor material. And then of course we need to make an if statement just like we did before and add a new floor material. And then in the next if statement we're going to append the material to the plane object like this. And then let's use nodes as well. And then we can go up to the previous material and copy the code for all of the different values or principal shader values. And then we can change the name to the floor material, which is the new material we created for the plane, and paste it into the rest of the lines. And then we can change the values so that it fits what we want for the floor. And this is the sort of darker color that I'm going to use for the floor. And then next, let's set the perspective to the camera so that when people run the add-on and select their song, they're going to look straight through the camera. So view perspective to the camera with capital letters. Okay, and then let's save one more time. And then it's time to import all of the modules that we need for this add-on. So let's start off by importing OS, which we need to interact with the computer operating system. And then next, let's import context, which we need to switch between all of the different editors, as we have already added to the script. And then we're going to use a template for the info. And then let's give our script a name so that we can differentiate it from the templates. So we're going to call it init.py, which we need for more complex add-on with other files and so on. And then let's give the add-on a name. I'm just going to call it Music Quiz Premium. And then the author will be you. And then we can just remove the rest of the location. It's not really necessary. Just going to say press N. And then you can add a description if you want to. I'm going to write music visualization. And we can just leave the category text empty. And then next, we need to import the string property, which is used for text, and the Boolean property, which is used for binary values, either true or false. And then the import helper is going to be used to open the file browser in Blender, so that we can open the music that we want to visualize. And then we're also going to import the operator, which we need for the button. And then import list here from the OS operator, and then let's save one more time. And then next, we need to use an operator template for the import button. But this time, we're not going to use the simple operator, but we're going to use the file import operator template. So let's select this one. And then we need to copy the import helper script. So let's copy all the way down here. And then paste it into our script. And then we can remove parts of the script. So let's remove the enum property. And then next, we can remove some of the comments, as well as the max lean value. Okay, and then let's also remove filename _ext, which is not useful for this music add-on. And then we can remove this comment as well. And then let's change the name of the operator. So I'm going to call it open file browser, and then the label can be open the file browser. And then let's set the default type to MP3, and call the bool property import music, and in the description we can write visualize the song that you have selected. Okay, and now let's save the file one more time. And then I'm going to change the name of the operator to OT_open music. And then in the execution function, I'm going to write file name, comma, extension. And then we're going to use self.filepath to add the song to the execution function. And then next we need to add all of the music visualization code to the execution function, so that we can execute it when we click on the button. And then press tab to indent, so that the code is within the execution function. And then next, we're going to use the simple operator code to get the return line. I'm going to add that at the end of the execution function, so that it works properly. And then let's save one more time. Okay, and then next we need to add a panel. So let's add a simple panel template and copy the code, including the draw function. And then let's paste it into our script. And then we can change the properties of this panel. So let's call it music panel. We can remove the comment, and for the label, we can set it to music panel. And then let's change the ID name to object pt music. And as always, we're going to place the add-on in the panel in the viewport. So it's view 3D for the space type, and then UI for the region type. And then set it to category. And the category will be the name of the add-on in the panel. And then next, let's add a label above the button. So label and then text equals. And then we can type in the text above the button. So I'm going to write generate bubble visualizer. And then next we need to set up the row for the layout. And then we're going to use row to create the operator, and this will be the button that opens the file browser and generates the music visualization. Okay, so this one runs the operator that we created earlier in this video, and the text on the button is going to be browse music, and then the icon we can use mesh and then UV sphere. And you can of course find other icons if you go into the icon viewer. Let's click on the plus sign, and this is where you find the rest of the icons. And you can enable this add-on, the icon viewer, under the add-on settings. Okay, so let's list the classes so that we can register them and unregister them. So we'll make sure to copy the names and paste it into the classes list. And then next we need to create the register function. And then we'll use a for loop to run through the classes and register them. And then we copy this code and use it for the unregistering as well. And we can reverse the unregistering. And at the end, we do the test that we always add to the add-ons. Okay, and let's say one more time. And then next, I'm going to fix some of the mistakes I made. And the reason why I include all of the mistakes is because a large part of add-on development, both for Blender and for other programs, is that you will spend most of the time fixing your mistakes and looking up functions online for fixing the problem that you want to solve. Because of my YouTube channel, I know a lot of the larger add-on developers for Blender who sells add-ons for a living, and they have told me that they spend most of their time either fixing bugs or looking up different Blender functions that can fix their problem on Google. So you need patience, and you have to expect to do a lot of mistakes that often can take a long time to fix. A thing that I forgot to do was to add the attack time to all of the bakes. So I'm going to add the 0.001 attack time to all of them. And then we can save the script for now. So go to text and then save as. And then we're going to create a new folder for the script, because we need a folder inside the add-on as well. And then we're going to select the HDRI and then copy it. So Control C or Command C, and then go to the add-on, add a new folder. We're going to call it HDRI, as we have specified in the script. And then we're going to paste the HDRI into the add-on. Okay, and then we can save the Blender file. And then we're going to compress the add-on. So going to make it into a zip file. And once the file is zipped, we can go into the preferences and try to enable the add-on. So let's install it. And when we try to enable the add-on, you'll see that there is an error at line 28. So we need to go back into the script and figure that out. So let's minimize the preferences and then go to line 28. And as you can see, we forgot to add the parentheses for the string property. And then let's give this another try. Save the Blender file, and then save the Python script. And then let's delete the previous zip and zip the add-on once again. So let's add to archive, then zip, then OK. And for Mac users, it's just compress. Okay, and then let's remove the previous one, and then install, and select the add-on once again. And we will see if we get any errors. Okay, so far so good. And then press N to open the panel. And then let's click on Browse Music and select a song. So let's select this one, and let's see what happens. And as you can see, it doesn't go back to the 3D viewport. And that is because of a typo at line 104. As you can see here. So let's check out line 104 and see what we did wrong. And at line 104, we have a typo. So we need to change it from UV type to UI type, of course. And then we're going to delete the previous code. And then let's save. And then compress it once again to a zip file. And then we need to open the add-on in the properties and install it. So let's remove the previous one and then install. And then of course we need to select the add-on, and we will see if we have any more errors. Okay, so let's browse for music. Let's find a song. And I'm eventually going to speed up this process because it's getting repetitive. And as you can see, we got another error. So we need to find the line with the error. And it seems to be related to the world. As you can see, we didn't get the background image. So let's go to those settings. And as you can see, we forgot to define SCN for the world. And this should enable us to get the background image working correctly with the folder. Okay, and then let's redo this process, compress it, and then let's install it in the preferences and see if it works. And I got the same error, and that is because I forgot to save the Python script. And that's another lesson. Always remember to save the Python script when you make edits. So let's save it one more time, and then go into the file browser, delete the previous add-on, and then zip it, and let's go into the preferences, install the add-on, enable it, and then let's try out some music. And we got another error, and this time it has to do with the environment texture. And once again, you can see the usefulness of the error message window, and we are able to fix the error. Okay, and then let's save the script, and once again compress the add-on. And let's see if it works. So let's save, delete the previous add-on, and then zip it. And it seems like I forgot one more typo. So I'm going to save, delete the previous add-on, and then zip it, and then enable it in the preferences. And then let's try out a song. Open, and as you can see, the add-on works. And that's it for this video. And when you have finished this add-on, my homework to you is to develop your own add-on with a different type of music visualization. Good luck with developing your own add-ons, and thanks for watching.